Hello everyone, this is Russ King. Thought I would share this quick little video with you about a little device, I guess you'd call it, that I find really fascinating. Hopefully you do too. And I call this video Fun with Temperature Data Loggers and Diagnosing Residential Comfort Problems. My name is Russ King and I'm a licensed mechanical engineer. I've been doing a lot of residential HVAC design. And the data loggers that I used were an older version of these that you see here. They're Dixon compact data loggers. They come in a 12 pack for about 700 bucks. It's about 60 bucks a piece. You have to buy the software for 100 bucks or so, I forget. They're about the size of a box of matches. They're easy to, put a little double stick adhesive tape on the back and stick them wherever you need them to go, or blue tape will hold them in place is fine. They come in two versions. Temperature only or temperature and humidity. Out here in California, it's a hot, dry climate because California made humidity illegal by code some time ago, and I only needed temperature readings. Basically, where you put the data loggers is the trick. If you got a 12 pack, you got a bunch of them to spread around the house. These particular houses were 2-zone, upstairs and downstairs, separate systems. But you got to have at least one outside. So put one data logger outside on the north side of the building in the shade. You don't want the sun to, really throw it off or anything like that. The other thing about data loggers is it's kind of like infrared cameras. You have to have a good extreme of temperatures. And I was lucky enough that this particular city, the design temperature, the summer design temperature was about 99 degrees, right around 100 degrees. And it went well above that. I think it hit 106. While I had the data loggers in these houses. So that was a great experiment. Obviously, if they're having cooling problems, you can't use data loggers to test the house in the spring or anything like that. But basically, put one outside for the outdoor temperature, and then you've got a bunch left over. You got to put one right next to the thermostat. That'll tell you the temperature at the thermostat. And then put several in what we call the problem rooms. You have to interview the homeowner and find out what rooms they're really not happy with, and put data loggers. Be sure to put data loggers in there. You can put one or two. Put one against the interior wall, put one somewhere farther out in the room, and kind of compare those. But also don't forget, put at least one or two in what we call good rooms. Ask the homeowner, say, on a really hot day, where do you like to hang out? What's the most comfortable room in the house? And then put some data loggers in there as well. And then here's the trick. The last one, put one right on the supply register. Take a piece of blue tape and tape it right over the face of a supply register. And what that does is it tells you as soon as the air conditioner turns on, and then as soon as it turns off. And when you see the graph, I call these icicles. And as soon as the air conditioner turns on, you'll see a real drastic spike going downwards as the temperature drops at the face of the register. And then as soon as the thermostat shuts off, as soon as the system shuts off, there'll be a little point at the end of the spike, and the temperature will start to rise back up. So that's the key. That's very important, and that helps a lot. So here's the first graph. So you see here, this was a 24 hours. So we got midnight, basically midnight to midnight. Okay. I believe this was September 11th, 2007. And here's the outdoor temperature at midnight. It's dropping down like so, and then the sun comes up. And you can see here's the daylight hours approximately. I didn't double check those, but basically 7 in the morning till 8 at night. And then the temperature rises back up, and it peaks right around 3 in the afternoon. And then the sun sets and the temperature drops back down. So it's pretty typical cycle for about a week, had these very same temperatures. So that's the outdoor temperature. The thermostat is this green line. And these homeowners, all these homeowners, I told them, set the thermostat to a comfortable temperature that you like, set it there, and don't touch it. That was very critical. I made them sign a disclaimer saying that they wouldn't touch it. So this particular house, they set it at 76, and so that's the green line. You can see the green temperature at the thermostat held right at 76 very well. Here's two rooms here, this pink one and this kind of brownish color one. You'll notice that when the sun comes up, they start to peak like that. They drift away from the thermostat temperature, so they're getting warmer than the thermostat. But the fact is, these two rooms were actually rooms that the homeowners considered good rooms. They said these are comfortable rooms. So a couple degrees like that doesn't really make that big of a difference. Okay, but you can see very obviously, and these were southeast facing, and you can kind of tell by the fact that they peaked, you know, in the morning they start rising up, the sun is hitting directly on those windows, and then as the sun passes by it starts to come back down, but you'll notice they drop back down to the comfortable temperature. Okay, this room, same house, two different rooms, and they had it set at 76 also. I think this was upstairs, I believe. So these two rooms were south facing, so you'll notice they peak a little later in the afternoon, right when the sun's peaking in the afternoon, and they drift away a little bit from the set temperature. They get up to about 78 or something like that, so not too bad. And again, these two rooms were not considered bad rooms. These were not rooms that the homeowners were complaining about, but you will notice that you can really see that they drift away, and this one kind of stays above for quite a long time, and that, as you'll see later, that's from poor air balance. That room is not getting the airflow proportional to that room's load, so that's why that happens. Okay, but it wasn't enough that the homeowners were complaining about it. This room, this was actually a different house. They had their thermostat set at 78 degrees, but you'll see this room is like, it's like, let's see, that's 85, so there's a 1 degree increment. It's about 82. Thermostat set at 78 is 82, but look at it, drifts way up to 82, 83, and never really comes back down to the temperature of the room. So that room, the temperature of the thermostat, that room was never getting enough air. So I believe, if I recall, this was a bedroom out over the garage, and they sized the duct to this bedroom the same as all the other bedrooms, even though this room had the bottom, the side, the front, and the top exposed, and it had windows on two sides. But they said, hey, it's a bedroom, it gets an 8-inch duct or a 6-inch duct, whatever, just like all the bedrooms. But they didn't do a load calculation, and this is what happens. This was a big problem. So this particular room here, and there's actually two rooms, there's this blue line and this kind of brownish color line here. You'll see this room gets way far away from the thermostat, up to like 88 degrees, 10 degrees higher than the thermostat. This was definitely a problem room. And even at night, look at even at night when the temperature drops down, this room stays warm, okay? And this other room, the blue line, didn't get quite as hot, but it does not recover as well as the other room, okay? And now here, this graph also shows what I call the icicle. So this pink line here, this is the data logger that's taped directly to a supply register in the house. It doesn't matter which one, they all turn on about the same time. The point is knowing when the system turns on and when the system turns off. So when this pink line drops right here, when it drops, that's the system turning on. And then right here at the bottom of the peak, when it goes back up, is when the system shuts off. So look at this, on, off, on, off, on, off. Look at all these, on, off, on, off, on, off. And look at the outdoor temperature. It's well over 100 degrees, and this system is cycling on and off. So here's the same house. Again, notice the pink line. The homeowners claimed that this system was undersized. That was what was causing this spike right here, was the fact that their air conditioner was not sized properly. It was undersized for the load of the house. But I told them, I said, nope, you know, obviously I did load calcs on your house, and I don't think your equipment is undersized, and they didn't believe me, so that's how we ended up putting data loggers in these houses. But clearly you can see that even when it's a good 4 or 5 degrees above the design temperature for this house, the air conditioner is cycling on and off. And these are 1 hour increments here, so that's about, you know, 1 per hour or less. Some of these are 30-minute cycles, on, off, on, off, on, off, on, off, on, off. The temperature at the thermostat is staying pretty steady. It's just that these two particular rooms were not working very well. Again, let's see, the outdoor temperature here. So the thermostat is set at 78 degrees, but look at the outdoor temperature. Here it drops past the 78 degree mark, and it actually gets pretty cool at night. It gets down to 70 degrees at night, but your air conditioner is still cycling on and off. This particular house had several problems, not the least of which was very poor or inadequate attic ventilation. So the attic in this house was staying hot and causing this AC to turn on and off, even though the outdoor temperature was lower than the indoor temperature, and you would think that heat would be escaping from this house. So why is the air conditioner turning on? And the reason is all this heat is stored up in the attic. And so as soon as the sun comes out, the attic gets even hotter. And look at these short cycles. Look at boom, 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 boom. That's crazy. That is a sure sign of an undersized air conditioner. So very, very common, very typical of houses with poor HVAC design. So this is a classic example of oversized equipment and undersized ducts. And this just illustrates the importance of doing a good HVAC design, doing load calcs, doing good equipment sizing, and doing a good duct design. So these spikes here are caused by bad duct design. These are caused by poor equipment sizing, by oversizing the equipment. And my experience, and I've done a lot of these diagnostics on homes, trying to figure out what's wrong with them, why they're not comfortable, even though the equipment, according to the installer, is operating perfectly. Trying to figure out why the homeowner's not happy. The vast majority of these are caused by oversized equipment and undersized ducts. And I will tell you that oversized equipment will cause as many comfort complaints, if not more comfort complaints, than undersized equipment. Now this one, this one's a little different. This one's zoomed in a little bit. It's only 18 hours, so it goes from, what, 10 in the morning until 3 in the evening. Here's the outdoor temperature. It looks a little different because it's a little stretched out. But I wanted to focus in on this one. I call this the crazy house, and this is why I refer to data loggers as lie detectors. These homeowners, I basically, like I said, I had all the homeowners sign a disclaimer or waiver or whatever saying that they promised that they would set the temperature on the thermostat and they wouldn't mess with it. Well, I downloaded this data logger and I knew right away that these homeowners were lying to me. They assured me that they would set it, that they actually liked the house a little bit warmer. They set it at 80 degrees and they left it there even when they went to work, and that's what I asked them to do. But when I downloaded this data, I said right away, I knew no, that's not what's going on. So if you look at the outdoor temperature rising up, getting over 105 on this day. So you look at the green line is the thermostat. So the temperature of the thermostat when the sun comes out is 85 and it starts rising up and rising up. This pink line is the temperature at the face of a supply register. So it's tracking the thermostat temperature a little bit. Notice a little bit higher, which makes sense because it's up by the ceiling. Okay, and this is a room. This brown line is a room and the green line is a thermostat. And then at 5 in the evening, when it hits 92 degrees in the house, the air conditioner suddenly comes on. And it drops down, drops down, and then it runs for 3 hours from 5, 6, 7 to 8 o'clock at night. The air conditioner runs continuously, and then at 8 o'clock at night it shuts off, and it shuts off when the thermostat is about 85 degrees. Okay, and then it shuts off, and then a little while later it comes back on and runs for another hour or so until 9 o'clock, and then it starts short cycling, or cycling I should say. Okay, so you could tell right there that the homeowners left this thermostat off during the day. Okay, and then when they get home at 5 o'clock they turn it on and expect it to cool down to a comfortable temperature. Well, look what the room temperature, the thermostat temperature is 90 degrees inside their house. All that thermal mass, all that sheetrock and everything inside the house is not going to cool down quickly. And they were complaining about the design of this HVAC system. Come on, people, this is poor operation on top of a bad design. So they're just making it worse. All right, so this is the kind of stuff we see. Also notice that even when the outdoor temperature drops down, you've got all that thermal mass inside the house still making the house warm, plus the attic is underventilated. So there you go. So thanks everyone. For more information on residential HVAC design software, please visit quickmodel.com. And for more ramblings on general residential HVAC design topics by me, please visit my blog at www.russellking.me. Also, check out my book, HVAC 1.0 Introduction to Residential HVAC Systems, available on Amazon or at www.sierrabuildingscience.com. Thanks, everyone. Have a great day.